First, let me share my agenda. Why we need logging and monitoring. This is my first part. Second is about history and evolution on logging and monitoring. The third part, okay, sorry, I will close. Okay, there is some background noise. So, okay, let me resume. Um, After the third part, logging and monitoring components introduced, I will sharing about 20 minutes live demo for logging and monitoring on Rancher. Yeah, section one, why we need logging and monitoring. Uh, as you can see here in the left, this is the first generation of computer named Mark II. People need to do a lot of work to find the issue on that. In the button, we can see the first real bugger. Uh, it is in the museum now. And currently, with logging and monitoring technology, people can easily recognize their bugger and uh, can do debug very faster. Here I will share a real story from my side. Last week, two team members from my team doing some big data program coding. They found an issue. They tried to connect their application to the HBase database, but they found the collection established, but there are no result come out. They asked me for help. I see their screen. There's only JVM start information. So I told them, how about you to writing some log4j configuration on that? After they started the log4j, they very quickly found the uh, configuration error. It's in the console, very directly to see the error message. So if without log and monitoring technology, people using the traditional debugger tools, it's a waste of time. Even senior developer cannot resolve the problem very fast. Okay, let's go to the second session. History and evolutionary. Uh, I break the history into the four ages: Stone Age, Agriculture Age, Industry Age, and AI Age. First, before 2001, I called it's a Stone Age. People using system out to print to writing, logging, and monitoring your application. The second is Agriculture Age. Here, from 2001 to 2014, with the technology of Log4j and JConsole come out, people can do logging and monitoring better. Currently, we are in the industry age. It's from 2014 till now. With the Kubernetes and the range technology come out, people can do logging and monitoring more visualized. Next age will be the future, the AI age. It's from now. You see, the AI have already changed our life. Let's see what people do in the Stone Age. I think everyone have this experience in your memory. We writing some hello world using outprint. It's logging directly to the console, and it's very easy to learn and use. For at that age, people do not have monitoring tools. People using a manual logger to send the system information to the console. Next, I call it agriculture age. Now, in this age, we have Log4j, SF4j, Logbacker, etc., a bunch of logging tools. The target not only console, but we have file, message queue, network, etc. People can using a bunch of monitoring tools. With the JMax technology, we have JConsole, JVM. The monitoring target can be web or visualized application. Let's see what's the evolution from storage. For the logging part, Maven repository have come out. We can find a bunch of logging tools from the repository. For the monitoring part, visualize the dashboard have come out. Okay, currently we are in the industry age. I call it cloud age. Uh, Cloud is more and more popular. We have Kubernetes. I call it Kubernetes as a aircraft carrier. Why I call it aircraft carrier? Because Kubernetes is very complex. Um, it's need a lot of time to learn how to use it. And Kubernetes can deploy on any cloud. The second tool I want to introduce is Rancher. I call it aircraft carrier control station because it have the visualized dashboard. It helps DevOps a lot. Uh, we also have cloud-native logging and monitoring tools like Elasticsearch, Logstash, Kibana, Beats, Grafana, and so on. Later, I will introduce them one by one. Let's see the evolution from agriculture age. Logging and monitoring become a part of Pro service which provided by lots of cloud company. Yes, you can find Kubernetes on any cloud, and you can find Elasticsearch on this lots of cloud market. Currently, we are not search components on Maven repository, but we are searching PaaS service on the cloud market. So that's a great evolution and in progress. People not using the jar and using uh, the native the small components to write code, but using the existing service to build their platform. Let's see in the future what AI can help us. I call this age AI age. Um, as microservice become more and more popular, I see today here a lot several topic is related to microservice. So microservice become more and more popular, but it raises another issue. The logger is distributed on different machines, so people can not easily collect them and read them. People can also cannot read the logger line by line, but with the AI help, machine can do that. The AI machine also can do 24 hours tracking, identify, and again for the cyber security threats. One one AI find some issue, it can alerting people uh, with social media like WeChat, and email and other notification tools. Let's see the workflow here. Application send logger and metrics to the AI automation uh, and AI automation will do some process. The DevOps only make the decision. Now the AI age of logging and monitoring is coming. Why I say that? Because Elastic Stack has already had the machine learning feature. It can here find, anomalies and outliers, forecast based on trends, and identify areas of interest in application data. So currently AI start help us. Section 3. Uh, let's see logging and monitoring components. I will list logging and monitoring tools, and I will do the comparison for logging Logstash and Fluentd, which is for logging. I will share the deployment architecture. I will share the monitoring with Prometheus and Grafana. First, let's see the logging components. Here, applications will send log to Logstash. Logstash can do some transformation and send it to Elasticsearch. Elasticsearch do the search and analyze work. The Kibana is responsible for visualize and measurement. Here, Fluentd can be replaced Logstash, which I will introduce later. For the monitoring and alerting, we have this process. System matrix can be sent to Prometheus, and the alert manager will check the states. If it meets the configuration, it will send the alert information to the end user. The Prometheus can be the database for Grafana. The Grafana is a visualized dashboard. It is based on the web. Here I will do some comparison from Logstash and Fluentd. We can see here in the left, uh, the Logstash is more suitable for the traditional virtual machine because the Logstash is more suitable for people to formatting the logger and send to Logstash. But if you want to pull the logger to Logstash, you need to add another components which named Firebase. It's in the left, in the right, we have Fluentd. Fluentd can pull the doc loggers directly and send it to the Elasticsearch. So it's more suitable for Kubernetes. Here is a performance comparison. Uh, Logstash seems have the best performance, which is very good performance, but it has still have small small plugins to support it. The Fluentd seems to have twice performance than Logstash. Here is a conclusion for comparison. We can see here Logstash is from Elastic Stack company, and Fluentd graduated from Cloud Native Computer Foundation. For the language, Logstash using JRuby, which means it needed JVM. Fluentd write with CRuby, so It's no need any JVM plugins. Logstash have 200 plugins supported. Fluentd has more than 500 supported. The performance, because ELK search need a JVM, so it need more memory. The transport, Logstash is lower. The enterprise support, they both have this. So from my side, I suggest using Fluentd in the production environment because of this comparison. Okay, let's see the simple architecture for the monitoring. Here in the left side, Kubernetes will have the metrics, and Prometheus will pull the metrics and store it in the persistent volume. The Grafana is used for the dashboard. Let's see the architecture for details. Here in the left, Kubernetes cluster have container. Every container have CPU, memory, storage information. It will send to the Prometheus client. It also will send KPI and API metrics to the Prometheus client. The client will register into service discovery components. Here we're using Eureka. And the Prometheus service here will find the client with the discovery service, and it will pull the data directly and collect it, then store it in the database. The Prometheus also supported the querying engine for query the Prometheus data. Here in the bottom, we have alert service. Administrator can configure our alert condition. Once uh, the state meets our condition, it will automatically send email, WeChat notification. In the right, we have KPI, API, CPU, and memory information, which is from Grafana Web UI. Okay, next is for a live demo. Here I want to share why we're using Kubernetes first. Then I will sharing how to install Rancher. After that, I will create a Kubernetes cluster, then create the storage. At last, I will launch logging and monitoring with Heim. Yeah. First, why we using Kubernetes for our platform? You know, why Java success? Because it's write once and run anywhere. Kubernetes extends this. It can deploy on any infrastructure now, and it can automatically deployment, scaling, and management of containerized application. Second, the idea is from Google. Google have more than 15 years experience of running production workloads. Third, the community growing is very fast. There's a lot of community for Kubernetes. At last, the very important thing, more than 70% of enterprise will using Kubernetes within 3 years. That's from a research company. So Kubernetes is very important now. But Kubernetes install is not very easy. Uh, with the Rancher, it can be very faster and easy. So I will share the live demo as the below process. First, I will share how to install a Rancher server. I will install Docker and NTP, set up a file war, and do the Docker Compose running. Second, I will create a Kubernetes cluster. I will add a node with Docker Commander. Third, I will create a storage. At last, I will launch our logging and monitoring with Helm. Yeah, let me close the video for better demo. Yeah, here I already have my uh, day demo machine. It's an Ubuntu system. Let me write using the script as I want to share. Here is the script. I will copy paste it. I will write a Docker Compose file. Yay. Docker Compose. Then I will launch it. Yeah, it's creating. Yeah. Let's see the logger. Yeah, it's starting. It will take times. So let me introduce how it will look like. Uh, the dashboard will look like this, and I will show the future while it's the launching. Rancher have role-based access control feature, and it can create Kubernetes cluster. I will show later. It can add a Kubernetes node to the cluster. And one great thing I very recommend you to use is upgrade Kubernetes version to the latest without downtime. It also supports Helm repository management. It integrating with monitoring system very well. Yeah. Let's see how it's starting. Yeah, still starting. Let's check. Yes, Rancher server have started. First time you need to set a admin password. Let's set it and agree. I'll click it, continue. The URL for your access this server. Now we have Rancher server started. Let's create a Kubernetes cluster. You can see here it supports lots of clouds. And in my demo, I will using the local VM. Maybe we call it Zday. for cluster name. Here we can define the member as a row-based access control, and we just leave the default setting. And here, because we have only one node, so we need to check all the node row on that uh, on this VM. Yeah. Let's copy paste and start it. Yeah, it started. You can see one new node has registered. Done. So it will take maybe 2 minutes to start. So let's go back to my presentation. How to create Kubernetes storage. Yeah, I will show it later in the demo, but let's introduce these 4 kinds of storage one by one. First is a local file system. Uh, the local file system is supported host parse, VMware, vSphere, Volume, and it's very easy for us to use. For remote file system, it supports the NFS, which I will show you later. The remote distributed file system, it supports chief and cluster file system. At last, it's a cloud file system. You can see lots of cloud file system can be supported, like Amazon ESB, Azure Disk, Azure File, Google Persistent Disk. Let's see, it's still launching. So let me introduce Helm. So what's Helm? What is Helm? Helm is like Linux Wing and apt package management. Uh, we can use it easily to do some package management. How deploy Helm? Here is here is the process. First, we need to have a Git repository to write our Helm code. Then we will build it within the Docker image. Then to test it, after you test it is successful, you can do the release. It will be sent to the Helm repository. Then the operation team can use it to do the upgrade or deployment. So why we using Helm? Um, yeah, Helm supported version control for deployment. When we're doing the upgrade and rollback, Helm chart, it is very easy and it's very testable. Uh, when we using the direct way writing some YAML on Kubernetes, it sometimes cannot have parameters setting. Later, I will show you how we can do the parameter setting with Helm. Waiting for API arrival. Yeah, it's nearly a success. Yeah, lovely. Everything seems created, and now we have this simple dashboard for the CPU, memory, and the pods usage. It also have the events for the Kubernetes. Now let's do the next step add a Helm repository to the cataloger. First, let me add a ELK search. Let me copy paste it. Sorry, it's very hard for me. Yeah, we can see here we have the cataloger, add a cataloger. I can rename this cataloger as ELK search using the Helm 3 version. Then create it. It will check and refresh it. Let's add another. Another one should be other charts. Put the name other charts. Also, we have Helm version 3. It will check it. Yeah, refreshed. Now we can deploy our Logstash. Sorry. We can deploy our application. We can see here. First, what I want to deploy is an FS plugin. Yeah, just leave everything as default. Yeah, we needed to waiting it to be started. It will be very fast. Yeah, it's running. Now we have the storage. Okay, let's deploy ELK search. Here we needed to do some configuration for that. Um, there will be a lot of configuration parameters. We can see from the describe here a lot of parameters we can using and change it. I just want to change some of them. Let me share. Yeah. For ELK search, I needed to change the climb for the templates. I will describe it later. Using edit. Yeah, because ELK search needs at least three node for the class setting. So it will check your nodes. But currently we have only one node. So we needed to using the soft to avoid the ELK search start check. And we using the read write mini to deploy it on one node. Let's launch it. Let's change the namespace. The namespace, yeah, we want it to use EFK. Let's launch it. Yeah, it's installing. Next is for Kibana. For Kibana, we want to using the same namespace, EFK, yeah, and without any change for the variable. Let's launch it. And we also need to Fluentd. Yeah, this chart. Fluentd. Yeah, integration with Elasticsearch. This one. Here we need to change the host name because the default host name is not exist. And launch it. Yeah. It will take more than 10 minutes to start, so I'm not want to waiting so long. I was showing what it would like shows like in our dev environment. Let's see. Yeah, this one. Need a login first. Yeah, we have that. You can see here in the dev environment, it have the same setting as I launched before. We have Elasticsearch, we have Fluentd, we have Kibana, which is started. Let's see what it should look like. The Kibana, it started loading. I just expose it with uh, the this service discovery. Okay, let me introduce the main feature of Kibana. You can see here uh, we can using the KQL to query the message filter like here, like some keyword I want to using message equals field. You see here, all the message will be highlighted, and I can change the data range, maybe 24 hours. Yeah, you can see we combine all the logger from lots of microservice together, and here we can do the aggregation. The logger can be searched together. Yeah. So this is the main feature we have for the logging today. Yeah. Next, let me show the monitoring. Still, Kibana is starting. Yeah, for today's demo. Let's come back to the home page. Here is a button. Just click it, enable monitoring to see the live metrics. And we just need to enable it. Yeah. The rancher have integrated other monitoring feature in it. Let's see what happened. Here we can see a new namespace created, and Grafana and Prometheus is starting. Uh, Let me share what it should be look like in our dev environment. Yeah, you can see here. Uh, the matrix is integration with the dashboard. Just click. You can see Grafana. It's loading. Yeah, it's the cluster information about CPU memory, storage, all these things. There's a lot of matrix here. I don't want to go through them one by one. So let me come back to our slides. So here I have all the live demo, and it's about 20 minutes. Just to require 20 minutes, you can have your uh, Rancher Kubernetes system. It's very easy for programmer to use. It's faster deployment, easy deployment. It have visualized the dashboard. It can deploy anywhere. Also, it have enterprise support. That's all from my topic today. And I think next should be the Q&A session. Let me check it. So the voice is perfect. Thank you. Looking forward to coming sharing. Yeah. I see the question from Bruce. How to check the version of Kubernetes installed? Is there any way to choose the Kubernetes version during installing Rancher? Yes, I can share with you the demo with this demo. Yeah, change the version. It's very easy. Let's come back to the setting for the cluster. Here we have the main version of Kubernetes. We can install it and uh, change it when we do the setup. After we started the Kubernetes, we can do the upgrade, cannot do the downgrade. Yeah, let's see next question. I'm waiting for more question. Can rancher suppose service mesh? Yeah, that's a good question. As ISO become more and more popular, ISO is one implement from uh, service mesh. So here, rancher supported ISO. The version is not the latest. The latest one should be 1.5, but you can try it in your dev environment. I not suggest you using it in production because it's not it's beta state yeah. Is Rancher the best management platform for Kubernetes? What's the best advantage of Rancher? Yeah, thanks for your question. Um, I think currently Rancher is mm, a good platform and it's very sustainable. I also checked with other kinds of Rancher kinds of management platform like Chin Cloud, but seems it's very not sustainable. So if you want to using it in production environment, I suggest you using Rancher. Water excellent tool to help and speed up dev and QA environment for Agile. Yeah, thank you. Let me see any question. Yeah, what's the best advantage for Rancher? I think for Rancher, Kubernetes is very important today, but it still need a lot of time to learn. And for the developer, if you are not focused on DevOps, it will wait. It spends a lot of time to learn Kubernetes. But the ranchers make these things to be very simple and easy. So I think the best advantage for rancher is to accelerate your learning time. Yeah, and you have visualized the platform. 1 more minute left. So as time's up, thanks for your time to to attend this topic. That's all for today. Thank you for your time. I will stop sharing.